Hello, and welcome to Tag1 TeamTalks, the webinar series about emerging web technologies. Today's episode is about Goose, a powerful and fast new open source load testing framework written in Rust and inspired by Locust. I'm Preston So, and I'll be the host and moderator of today's episode of Tag1 TeamTalks. However, I do want to address one thing before we begin. Last week, as of this recording, many of us saw and witnessed the awful incident that occurred in Minneapolis, and our hearts go out, obviously, not only from the Tag1 community, but also from all of us on the call and all of our families to the Black brothers and sisters, our Black loved ones and family members who have been dealing with unbelievable grief and unbelievable pain during this past week. We at Tag1 firmly believe that Black Lives Matter, and we support the members of not only our Black community, but also everyone around the world who is struggling with injustice. And with that, let's go ahead and introduce, first of all, our guest. But before we get there, I'd just like to take a quick moment of silence for George Floyd, Breonna Taylor, and everyone else who has been impacted by police brutality and police violence against the Black American community. Thank you very much. Today, we're going to be talking about Goose, and I'm joined today by three of my dear friends here at Tag1. We're joined today by Jeremy Andrews, who's currently located in Italy. He's the CEO and founding partner of Tag1 Consulting. We're also joined today by Fabien Franz, located in Switzerland, VP of Software Engineering at Tag1. And we're also joined today by Michael Myers in the Berkshires, Massachusetts, Managing Director of Tag1. And I'm located here in New York City, your Editor-in-Chief of Tag1 Consulting. So stepping back for a moment here, out of curiosity, Michael, why is a load testing framework so important? And why is it something that Tag1 is so interested in?
It's a great question and a good place to start. Studies clearly prove that the speed of your site impacts conversion rates, revenue, any user action, and even milliseconds matter. Walmart showed that when they improved their site, every 100 milliseconds their revenue went up 1%. Google sees abandonment of searches. And at scale as a business, that has a material impact on revenue. 1% incremental revenue, that's amazing. So, the slow pages clearly impact your business, and load testing tools help you figure out why your site isn't performing. And often, as a business, we get a lot of new clients for performance and scalability. And unfortunately, they typically come to us in an emergency situation. Their site's down, they're losing a lot of revenue and money. Foreo, a big Swedish beauty brand, multinational, with amazing growth. They went from 3 people to 3,000 employees, very quickly, and have built some amazing products. Their site went down during Black Friday, a critical sales event for a company. And, they called us up and we were able to scramble. Fabien, Jeremy did an amazing job, got them back online before Cyber Monday. And, the site was faster than ever, but it's a PR nightmare. They're losing a lot of money, and it's really important to address performance proactively. You want to avoid becoming a victim of your own success. And so we really encourage people to do that and make this part of their development process from the start. And that's another really important thing to mention. We're going to focus a lot about Goose as a technology and tool today, but load testing is a process, and it requires a scientific and thoughtful, methodical methodology. And we've covered that a lot in conference talks and other blog posts. So I'm not going to get into it too much here. We can post those links in the description. But, that's really important to mention. You need to be able to do things like test and simulate the same load over and over in a consistent and repeatable way to, get a good sense of how you're changing and tuning your infrastructure, and make, a change and then test, for example. Don't make lots of changes before you do the next round of testing. And so, think about the methodology when you're doing load testing. And with that, let's hop into Goose.
Absolutely. I think that, load testing is a very, very important concern, especially among Tag1's own client base. And, I'm very interested to hear about how Goose improves on a lot of the things that we saw in Locust. So without further ado, Jeremy and Fabien, what exactly is Goose and how does it work?
It's easier to understand Goose if you're already familiar with Locust, but essentially we took the same concepts that the Locust framework implements in Python, and we re-implemented them in Rust, which is a significantly faster language. So yeah, at a very high level, that's the difference.
I think it's important to talk about the pain point that brought you to writing Goose in the first place, and that is if we wanted to test something, we always had to set up several virtual machines. We had to load for distributed load testing to even generate the load necessary. And that is, whenever we were doing a load test in practice for one of those clients that Michael mentioned, we need to generate a lot of load because often we test the CDN. Often we test several things. So we need often to spin up at least 4 virtual machines just to be able to generate the load we need. And with Locust, where we'll be talking a little bit more later about, and basically you have to start a manager process, and then you start several worker processes. If you want to use CPUs more efficiently, you even have to start several worker processes on one thing. So that's very, very important in that. And that's a lot of effort for not much win, because what comes out in the end is that we always have to start up that VMs, but sometimes you just have a powerful Amazon instance, one VM or whatever, and you want to generate a lot of load, and you don't want to start so many workers and manager, etc. And this is what Jeremy has solved.
It's worth noting that Locust is written in Python, and Python suffers from a global interpreter lock, which is a mutex that wraps all of its memory management because it's not thread safe. And what all that means is that Locust cannot use more than one CPU to generate load. The only way to do it is to spin up a distributed test, like Fabien was talking about. And so if you have a 4-core VM and you want to use all of those cores, you actually have to spin up 5 Locust processes, 1 manager and 4 workers. Whereas with Goose, one of the things we've solved is there is no global interpreter lock. It just uses all the cores, 1 process, and they're all generating load at the same time.
Yeah, and I think so now this makes it 11 times faster already. So this is amazing.
Well, that's in addition, actually. So 11 times faster is not so much. It's got nothing to do with the cores. On top of all what we just talked about, Rust is a compiled language, and when you write the optimizations that it's able to put into the compiled binary, make it 11 times faster for what we're doing than a comparable load test in Locust.
So on a single core,
11 times faster. Whereas if you have a 4-core, with a single 4-core VM, 1 instance of Goose, you can generate the same load as you can generate with a swarm of Locusts of 44 Locust workers. Yeah, so it's much, much, much faster.
And I think this is not only a testament to the kind of the multi-core strategy that that is enabled by Goose, but also a testament to how Rust has really been optimized for this kind of performance and scalability. So exactly what led you to create Goose? I mean, one of the things that I think we've seen very often is that there's a lot of load testing frameworks out there. What led you to create Goose? Why add another one? What's the goal of Goose, and how is it different from the load testing frameworks in existence today?
Without a doubt, we were solving the pain points we were running into using Locust. It was our favorite load testing tool. It's a fantastic framework, but the things we've been talking about were what drove it initially, just to get that performance. On top of that, Rust has a different way of thinking about writing code. One of the advantages of Python is you can write code really, really quickly, but the end result is you don't always think through the consequences of bugs and errors. Load tests they cause problems intentionally, and so oftentimes your load test can actually have all these strange errors, and it can be hard to debug them. Locust will spit out this big backtrace. You have to go back and figure out what exactly went wrong. When you're writing in Rust, the language itself, the compiler, forces you to think through all possible code paths. And so it might take you slightly longer to write it the first time. But the end result is if something goes wrong, you're expecting it, and you can throw a friendly error. There's no ugly back traces. It's much, much more friendly to work with. So just
basically there's two things about it. First of all, we have to distinguish between systems languages like Go, C, C++, and Rust. And then we have to distinguish between normal languages like PHP, interpreted languages, JavaScript, Java to some extent. Those are basically just in time compiled or interpreted languages. And obviously a language that is closer to the hardware is much, much more important in that. But what Jeremy failed to mention here is a large thing about Rust, which is completely fascinating. You can write safe C code. It forces you to write safe code. It's very, very hard, unless you use the unsafe keyword, to even write unsafe code in Rust. And that's amazing because it has huge security implications. Microsoft, Firefox, Mozilla, they all do statistics, and memory errors like dereference pointers, overflows, whatever, they're like 70% of security bugs. And with Rust, those just do not happen. Obviously, for a load testing framework, security is not the point, but the point is if you make a mistake in your load test, then with Python, you find it during runtime. If you make a mistake in Rust for your load test, chances are high that if it's like not a logical error, but something more complex, that you find it already at compile time. So you don't have to write your load test, run it, wait for an hour, the load test fails with some obscure error, and you repeat this process over again, but you write your code, it fails immediately already during compilation. You fix it, and you have a smooth running load test. So this is a real point. So not only is Rust a language that gives us lots of advantages for the framework, but also for the one writing the load test. And this is so freaking cool.
It's also worth noting that it doesn't just benefit what we're writing. One of the advantages that you'll find with Python is there's a huge history of libraries that'll help you writing your load tests. Some are buggy, some are not, but they can definitely help you in writing it. When working in Rust, there's also libraries, and what I've been finding is that even newer libraries tend to be less buggy because of exactly what Fabien's describing. The compiler helps you to write correct code. And so it makes working and pulling in different packages a joy to work with.
I think one of the things that, I think is tough for people to understand who are looking at load testing and examining why it's such an important facet of performance and scalability, we just have to take a quick look at the kinds of clients, Fortune 100 companies that Tag1 works with to perform load testing and ensure that these applications operate at scale. So just to take a quick kind of step back here to just kind of level set with the audience who's listening to this right now. Why is it that we need to generate so much load? Why is it that load testing is so important to, especially those of us who are working with customers who really need that level of infrastructural soundness and stability?
Yeah, so what we do as one of the many things we do as a company is we tune servers, we optimize code, we make things run faster, and we make them run more at scale. But what that means is they can handle larger and larger loads. So in order to simulate enough load, we have to generate a very large load test. Some of our clients are Fortune 500 companies. Even their development infrastructures may have Akamai CDNs in front of it. So you're massively distributing the load that you're putting on it, and you just have to generate a lot of load to trigger the sorts of problems that you may be helping track down in the first place. So that helps with all of this. Beyond that, we've also been using it to the very first load test that Goose was used for was to work on a release of the Drupal Memcache module, and to make sure that the code is working, the load test tries to put stress on Memcache. And so with Goose, it's much, much easier to actually see Memcache become the bottleneck in your stack and to properly load test it.
Yeah, and another point is it's usually not used for it, but it can even be used for some kind of chaos testing. We recently wrote a load test where we were logging in as random users to ensure we have a realistic profile. And because we was logging in as random users and then doing some operations, basically it led to some of those operations failing and throwing errors, which would never have been found else. So it can be used for some kind of random chaos testing as well. It's usually not used for that, but that was a nice side effect of being able to find some bugs in that. So that was pretty cool. Yeah, and the other thing is, as Jeremy said, if you want to test Akamai, you need to generate a huge load, and we're talking about millions of requests per second. It's like whenever I look at those graphs and numbers, when we do those load tests for the top 500 companies, it's like, what? So much load, so much traffic. We generate so much traffic that we need to give Akamai, which is really huge, a heads up that we're doing a load test now, so that they are aware that this is like legitimate load that's coming here, and not some distributed denial of service attack.
In addition to generating load, it's not just that we're trying to create a lot of noise on the network, but we're generating valid traffic, which is a key point, and then verifying that what comes back is correct. It's checking headers, it's checking, inspecting the text that's returned. Something that Python gives you tools to do, but takes a long time and it's hard to do at scale. Whereas the tools in Goose are, we're finding, about 11 times faster.
Yeah, and the other point about load tests in general is, for example, you have this problem, you need to ensure that your responses on the Akamai network are properly cached, and you're not getting like the wrong headers or whatever's like that. And when we want to do this correctness test, it would have been a long time to do that in the code alone and to ensure we have all the edge cases, etc., especially with static files in the mix. So what we basically did is we enhanced the load test to also do some correctness checking in that we have the correct cache headers, that things are properly cached, etc. So that's a nice thing. You can easily extend a load test to also be like a little bit testing framework, but not for testing things in that, but for testing performance characteristics, like, is it fast? Is it having the right headers? Is it having a TTL that's long enough, etc.? So there's lots of flexibility you can have here with the load testing tool, besides generating load, obviously.
Jeremy, if I remember correctly, one of the awesome things about Python are like libraries like Beautiful Soup, right? That make it super easy to run load tests. But as you scale up to get load, don't you need to remove those, like switch to regular expressions to get even faster, which sort of negates some of the benefit? And if so, I would imagine, Rust has similar libraries to make it easier. Is the 11 times faster? What is that comparison? Is Python running, is Locust running Beautiful Soup? Are these stripped back? So
as you do more things with a load test, Goose becomes drastically faster in comparison to Locust. So if we use Beautiful Soup to process the text, and we use the equivalent select library on Rust in Goose, it's actually way faster. I think in the test I had, it was 30 times faster when you were using all the convenience functions that you want to use when you're writing load tests if you can. Stripping away Beautiful Soup and putting in regular expressions was about a 5 times performance boost. And then when we stripped out the standard client that Locust uses to their fast client, we got another double in speed. We saw similar improvements on the Goose side as we stripped out the library and we used their regular expressions. We again got this speed boost. The one thing we've not tried yet on the Goose side to optimize is pulling out request and using a more high performance client, such as Hyper. And expectations are that we can see significant boosts further, but at some point, convenience is worth it. And since we're already so fast and we can use all the cores, realistically, we're not going to have to worry too much about adding drastically more performance to Goose. To specifically answer your question, the 11 times faster is both tests fully optimized.
We've heard a lot about sort of the advantages of Goose over some of the other solutions out there. And I know that, for example, Tag1 is a huge contributor to open source projects. And as I understand it, Locust is open source. So I'm kind of curious, why is it that Tag1 has gone in this direction to open up and establish and pursue a new open source project rather than improving Locust? I imagine it has something to do with the language underlying Locust as well.
Indeed. Yeah, I mean, Locust is great, and they continue to improve it. New release just came out with some new features, and that's fantastic. The fundamental problem we're having is we can't scale up load enough without a lot of overhead. And so the fundamental problem is that Locust is written in Python. Goose is intended to be incredibly similar, but written in Rust. And that also is part of the inspiration, is that I've been really intrigued by Rust for the past, I don't know, year or so. And Goose was the first project that was a perfect fit that matched both, what we do in our day job here at Tag1, but also with just diving more into Rust. So it was a great excuse to do that. And absolutely, Goose has been open source from day one. You can go back and look at the original commits, which it's come a long ways in the last, 3 months that it's been around.
Yeah, for example, Jeremy recently introduced async, which was a huge hassle because async is still pretty young in Rust itself, but it gave a 2 times performance improvement. So it was pretty cool in that that async. There's also it's interesting if you go to languages like C, C++, or whatever. They're still lively. They still have changes, etc. But they don't have this explorer spirit, I call it, like a new open source project like Goose itself. Rust itself also is fairly young for a language, and they're like doing amazing academic work, etc. And in futures, the design is, I think, from 2016 or something, and now in 2018 and 19 they finally got it into the language itself, and then the async keyword, etc. So it's amazing to not only see like use something as open source, but also use some other open source that's still in development. Basically, you run into insane bugs, you run into strange things where you're like, why is that not working? And then you have to write macros or whatever. But what I want to say with that is it's incredibly exciting to use Rust because it's something that's still being developed, that's still being made faster, more secure, and otherwise by their authors. And that's very different comparison, maybe comparable for our audience, mostly Drupal based, in when PHP 7 came out, and it was so much faster and so much different than everything that had been come before.
It's worth noting, going back to open source and talking about async, that was actually the first open source patch we got. Somebody in the community read a blog on our website and contributed back. He said he was going to spend a half hour and just plunk it out while watching his roommates play a game. And then he ended up spending 4 hours, and it grew into like a couple weeks of effort. But it was fantastic. It was great, meeting somebody new from the Rust community who just kept working with us on it until we got it to a way that works really nicely, that we're really happy with. So.
I think Rust has definitely gained a lot of momentum, especially over the last year or so. I think, we see a lot of really amazing applications for Rust, not just in things like microservices, but also load testing tools. And it's really amazing to see Goose join that list. It's been great to see the adoption of Rust continue to grow.
Yeah, definitely. I mean, Microsoft just recently announced that they now have a complete bindings for Rust for their standard Windows library in that. So they're a huge user of that. Firefox is trying to write a whole browser core in Rust. It's still experimental, but they're making great progress in that. And it's fascinating to see. If someone wants to look at something fascinating, Rust is definitely, it has a steep learning curve for several things because you need to know about threads, etc. But if you look at it, it's just great.
For anyone who's looking for a good primer to the Rust language, I highly recommend my friend, actually here in New York, Steve Klabnik's book, The Rust Programming Language by No Starch Press. Amazing guide to Rust. I haven't really made much of a dent in it, but it's an amazing title for those of you looking for more information about Rust. Goose is, obviously a very new and up-and-coming open source project, still in its infancy, obviously, and we'll be doing a lot here at Tag1, of course, to showcase the benefits of Goose and introduce it to the wider open source community. But one of the things that I think is very important, especially in the context of these open source ecosystems, is how can people help? What can some people in the community do in the Rust world, or, for example, in the worlds that we play in Drupal, PHP, and the web space? How can people help out with Rust? Maybe not just actually contributing Rust code, but what are some other things that people can do to get involved in helping out with Goose?
Yeah, there's a lot that can be done. Just using it, just trying it out is the first thing. And then providing feedback, what works, what doesn't work. Requests to say, hey, this is great, but we would like, if you could fix this or add this feature, reporting bugs if you run into bugs, all of those types of things are huge in the open source community. Pull requests with code changes are always welcome, of course, but they're in no way required. Currently, Goose has decent documentation. It's got some auto-generated documentation that's built into the code, and the GitHub page has a basic tutorial. But what would be fantastic is seeing more Rust style, like a Goose book, and that's something that somebody actually using it could start working and contributing on. That would be fantastic. Especially if you start adding recipes and little tips and tricks and things that you've done in your own load tests. Kind of in the similar vein, it currently only has 2 examples, a very simple one, and then the load test that we use for the Drupal Memcache module. If people wanted to contribute more load tests, they're pretty easy to write, and you could bring in different third-party libraries, give examples of setting cookies or doing whatever fancy things that is unique to your environment. That'd be helpful to everybody. And personally, what I'm waiting for is when other people start talking about it. I'll look forward to when somebody else writes a blog about it, or I see a tutorial pop up somewhere. That's when I'll be happy with its success.
Yeah, also Jeremy has lots of issues tagged with good first issue, which GitHub encourages you to do, so that people that want to contribute, that want to dive into open source, maybe there are some people out there that are just learning Rust and they just want to dip their toes in a project. The best way to learn is really to just take something and dive right in, try to solve a problem, bang your head around for a few hours or maybe not, and really dive into it, create a little patch, and it gives you so much more understanding of something than just reading a book, learning, writing hello world, doing that. For me, the best way to learn is to contribute patches or review patches on open source projects. There's no faster way. It's like the fast track to being a rock star.
Absolutely.
It's really good to contribute to a project that Fabien's involved with, because he's an amazing reviewer. He catches little details that you didn't think mattered. He leaves comments that makes it clear that he's really reading through, understanding every little bit. He's fantastic.
I can definitely corroborate that. Fabien's an incredible, an incredible asset to have as a code reviewer, and of course as a wonderful engineer. And I definitely hope that as a lot of us in the Tag1 community are learning about Rust, and I do have to make a quick correction. That book that I named earlier is actually written by 2 people, Steve Klabnik and Carol Nichols. Didn't want to leave off that second author. And hopefully we'll see a lot of folks learning Rust, getting involved in the Goose community, getting involved in contribution, opening new issues, and of course offering their insights as well from their ample knowledge. So with that, I wanted to dive a little bit into the kind of vision ahead for Goose. What exactly is going to be coming in the next couple months? I mean, I know that right now we're still in early stages. Jeremy, you mentioned you want to have more people writing about Goose. I definitely want to look at doing that on my blog and thinking about some of the ways that people outside of sort of the Rust and PHP communities can really benefit from this. But at the same time, I think a lot of folks are also looking at Goose as a potential amazing future-ready, future-proof tool that can not only improve the way that we do load tests today, but also map out how load tests will be run in the future. So what's the roadmap for Goose look like?
We're still reviewing its performance right now. As fast as it is, our adoption of async is pretty new, so we're making sure that we're leveraging it everywhere we can and where it makes sense. But beyond performance, one thing, currently it does spit out incredibly useful running statistics, and also at the very end it gives you a summary of all the requests that it made, how long each one took, average time, those sorts of statistics. What we were going to add is also the ability to log every single request, be it to a local CSV log file or remotely to a graphing system server or something, so that you can actually get some real-time graphing. Beyond that, it currently is using the Rust request library, and it's great. It's very easy to use, but there's quite a few others out there. And so the intent is to try to abstract it a little bit so that you can swap out whichever client you prefer. In some cases, that may give you better performance. In some cases, it may just give you the features you need, or it may just be that you're more comfortable with another client. So why not be able to use it? Beyond HTTP and HTTPS, we also want to start adding support for other protocols as well. There's a request from the community already to add support for gRPC, for example. Also, Rust has native support for WebAssembly, and so Goose is screaming for a simple UI, and certainly we will leverage the latest and greatest. We'll use WebAssembly, and so you can control the load tests and view statistics in real time. And beyond that, we recently added Gaggle support, so that we can do distributed load tests. And so we'll probably explore ways to further simplify spinning up Gaggles. At this point, the largest Gaggle we've ran was 1 manager and 100 workers, which can create just an absurd amount of traffic. So it's working well, but there's lots more improvements we can make there.
Absolutely. And one thing I wanted to ask, which is something that I think a lot of us are interested in from the standpoint of how exactly Goose will be supported in kind of the long run, is what's Tag1's plan around Goose? Is there any plan to offer services or a plan to offer anything surrounding the Goose ecosystem from the standpoint of Tag1?
We've talked about it. It's possible. It's certainly possible. At minimum, it makes our job better to be able to use Goose to create load tests. And so certainly our clients are going to start seeing it more and more. Whether or not we expand beyond that is yet to be seen, but we hope to. Michael, for one, is really excited about it, in fact.
I really love Goose. I love the name, the homage to Locust. I appreciate you making the Goose attack and the command to run it. I lobbied hard for that. But it's clearly something that we as a company and you are passionate about, and it's fun to work on.
Yeah. Well, I'm very excited to see a huge community around Goose start to develop, and especially a lot of people start to honk in support of good load testing. Alrighty, and with that, obviously, of course, we'll be doing a lot more content coming up about Goose, and we'll be sharing more about this exciting project and this exciting ecosystem around one of the fastest and most impressive load testing tools that's currently out there. And now for something a little different. We have this thing called the Aside Tag here at Tag1 TeamTalks, where we go into a little bit of what's going on in our real lives. So I want to take just a few minutes to allow for each of us to share a little bit about what's going on with the audience that doesn't have to do with Goose. Why don't we start with you, Fabien?
Sure. I'll be keeping in Rust land because while researching Rust for Goose a little bit, I came across something really cool, and it's a PHP RS, with which you can write full PHP extensions in Rust. And that'd be pretty cool. And I plan to be doing, no idea when, but still planning it, and to be doing a little xhprof shim, which will be calling Tideways xhprof. And that's so important for me because currently, if you use PHP 7, there's a huge confusion of which xhprof, which is our profiling tool we use for PHP, and we use in combination with load testing for performance optimization, you use. Which one should you use? There's one official on Pickle, it's based on the old Facebook, and there's this rewrite by Takeways, but you have to always write sideways HHprof enable, so people are not using it. But I've reviewed the code of both extensions, the C code, and the sideways HHprof is not using PHP data structures to store things, so it has way less function overhead. It's definitely the better extension, and I hope with that little Rust PHP bridge thingy, I can just provide people that have XHprof tools to just use them, continue to use them with sideways, and just build this little bridge. So that's what I'm excited about.
Wonderful. That's really exciting. How about you, Jeremy?
Yeah, my family and I moved to Tuscany, I don't know, 5 years ago, I guess. And one of the things about Tuscany that is appealing is the romance of vineyards and grapes and wine. And so I've started planting some vines in my backyard, and it's been just fantastic. Learning what the different vines look like. They're now growing, and so I have to learn things like green pruning, when to prune and how to prune, and training them, how they're supposed to grow for the optimal to get the best sun. Whether you should water them, when you should water them, spraying them to avoid funguses. There's just so much to it, and hopefully at some point I will also have the pleasure of drinking my own. But for now, I'm just sampling the locals and figuring out what I can strive for.
That's amazing, and I'm very, Jeremy, I'm very jealous to see you having that sip of wine because it's barely 8:50 a.m. here in New York City. All right, what about you, Michael? What's going on in your world?
Well, I'm eagerly awaiting my first bottle of Jeremy's vintage, so I'm excited to hear about his work on the vineyards. That's super cool. I've talked a lot about cooking in our segments here. Is one of the things that I've had an opportunity to do a lot more of lately, and I'm really excited about it. I've learned a lot of skills. One of the things that I love, and I think a lot of people love, are French fries. And I also make like little chips, and they were good, but they were just never like as crispy as I wanted them, or at least uniformly crispy. And it turns out that the getting them more crispy took three things. One was soaking them in water to remove the starch, and sort of replacing that water and letting them sit there for a while, an hour or two at least. And then I put them on a baking sheet, and so there isn't like a huge mess, because they're covered in, an olive oil or something. I used to put foil down, but apparently parchment paper is a much better approach. It helps, with the crispiness. And lastly, the third thing was 2-temperature baking. So you do it like 350 for, 10, 15 minutes to get them nice and soft. And then you jack it up to 425 plus, and kind of keep an eye on them at that point, because you don't want too crispy. And then you bake them for another 10 minutes or so at that high temperature. And the trifecta, they're not all 100% crispy, but they're definitely better. And so I'm excited to iterate on my fries. And if there are any tips out there to how to make them even better, of course frying them would be amazing, but any tips to make better fries and chips?
They're really good with red wine.
The perfect pairing.
And a burger or something. And it's summertime now, so please email me, letter M at tag1consulting.com. I send your baking tips and cooking ideas, recipes. Oh my gosh, I'd love it.
All I know is whatever kind of fry it is, Old Bay just makes it better. And out of curiosity, I've never done this before, but I'm, really curious to hear, what's everyone's favorite cut of fry? Is it steak fries? Is it curly fries? Is it, I forget what you call the McDonald's cut of fries, but I definitely like steak fries myself, but I know that that's not something everyone else shares.
I lean towards chips, like really thin, slicing the potato into round circles, because they get really crispy when they're thin. But I would say McDonald's style fries, like the thin, for the same reason, more crisp, more surface area ratio per fry for crisp.
How about you, Jeremy and Fabien? What are your preferences?
I personally, when I make fries these days, I actually cut them into pretty small pieces. And the reason is we have 2 toddlers. And I try to make something that especially my son won't choke on.
Yeah, and for me, also just a McDonald's style fries, like very, so they're very crispy.
I love it. All right, and now it's my turn. I do want to go ahead and devote my aside tag today to Black Lives Matter and to making sure that we do our part to tear down a lot of the institutional racism and structures that we have in our country. One of the things that I would like to encourage all of us to do on the Tag1 TeamTalks community is please find organizations that could use your donations, whether that's the NAACP, whether that's Black Visions Collective, Fair Fight Action, or any of the bail funds that are currently operating. I also want to highlight the fact that it's a really amazing thing to work at an organization like Tag1 that is focused on upholding democracy and social justice. One of the organizations that Tag1 works with, in fact, is an organization that I highly recommend our community contribute to, and that is the American Civil Liberties Union, as well as, of course, the Network for Good, both organizations that are doing amazing things for social justice in this country and civil rights. Alrighty, well, with that, I did want to go ahead and say that Goose is out there, ready for the downloading, ready for the dependency declarating. All the links that we mentioned today are posted online with the talk. If you're interested in looking at Goose, if you're interested in any of the things that we mentioned around Goose today. And as always, if you're really appreciating this talk today, if you really enjoyed hearing about Goose and some of the benefits that a Rust-driven load testing tool has over a lot of the alternatives out there, please feel free to upvote, subscribe, share this talk with those of your friends and family who are interested in Rust as well as load testing. And check out past talks at tag1.com/tagteamtalks. If you want to hear about a particular topic or a particular subject, please reach out to us at tag1consulting.com. I want to thank my dear friends and colleagues today, Jeremy Andrews, Fabien Franz, and Michael Myers, all of us here at Tag1. Really appreciate you joining us today, and until next time.